The atmosphere over America has stopped moving. The polar jet stream that normally drags weather across the country from west to east in 3 to 5 day cycles has slowed down. The waves in it have amplified into a textbook omega block, and the configuration is forecast to lock in place through the opening 4 days of meteorological summer. 5 regional National Weather Service offices and the National Weather Prediction Centre are all naming the configuration explicitly this morning, which they almost never do. The reason they are naming it is that the consequence of the block holding is a multi-day, multi-region, continental flood pulse forecast to begin Sunday over the northern Rockies and worsen across the southeast through the first week of June. If this has you hooked, subscribe to the Sky Lab, because we are about to walk you through every part of what this configuration is going to do. Drop a comment telling me where you are watching from and what you remember from the last time a flood pattern locked in over your region. Let's break this down. Part 1. The pattern. The sky is drawing above America. There is a shape parked above the United States right now that should not be there. It is a shape that meteorologists do not normally name out loud. It is a shape that, when it does form, has a specific way of locking the continent in place underneath it for 1 to 2 weeks at a time. And this morning, on Thursday, May 28th, 2026, multiple regional offices of the National Weather Service, the National Weather Prediction Centre, and several independent atmospheric scientists all named it at the same time. They called it an omega block, and they used the words slow-moving. Those two phrases, said together, in the same morning, by people who almost never speak in those terms casually, are the reason this video exists. The omega block takes its name from the Greek capital letter, omega. Picture the letter in your mind for a moment. A central upward bulge flanked by 2 downward curves on either side. That is the shape the atmosphere has drawn over the lower 48 states this week. A high-pressure ridge of warmth is bulging upward through the central United States and into Canada. To the west of that ridge, sitting over the Sierra Nevada and central California, a closed upper-level low is spinning in place. To the east of the ridge, parked over southeastern Canada and New England, a second closed upper-level low is spinning in place. The whole structure spans the continent, and it is not moving. The Weather Prediction Centre described it this way in its national discussion issued at 3:22 in the morning Eastern Time. An amplified upper-level synoptic pattern will remain in place into early next week, before turning more zonal mid to late week. Overall, the general pattern will feature troughing over both the west and east, with ridging in between. That is the shape. That is the omega. The forecast office in Chicago described it this way. A mid-upper level omega blocking pattern is taking shape across the CONUS this morning, with high amplitude ridging across the central CONUS and Canada, centered between a broad closed low over California and another over southeastern Canada. The forecast office in Philadelphia said this. An omega block sets up over the central US, with our area being positioned on the eastern side of the block. The forecast office in Los Angeles said this. One more day of odd for late May, weather courtesy of a late-season upper low that is the western part of a CONUS-spanning omega block. The forecast office in Boston said this. There is a good consensus among ensemble guidance for a blocky upper-level pattern to set up over the northeast featuring upper troughing Friday through early next week. The forecast office in New York said this. A series of upper-level disturbances dropping southeast across eastern Canada will carve out an upper trough across the northeast into the Canadian Maritimes. 5 regional offices, 1 national centre, the same shape named, on the same morning, with almost identical language. This does not happen often. The forecast offices of the National Weather Service write hundreds of area forecast discussions every single day, and the vast majority of them describe the day's weather in functional granular terms. They talk about cold fronts and short waves and stalled boundaries. They do not, as a rule, invoke synoptic blocking patterns by name unless those patterns are unmistakable. The fact that 5 offices and a national centre are all naming this configuration on the same morning is by itself the synoptic anomaly. They are not naming it because they have to. They are naming it because they want you to understand what is locking in. And then the public-facing forecast convergence on the same configuration. Flooding risks will rise across the United States into June as the slow-moving omega block pattern takes hold. This weekend, tropical moisture from the sultry Pacific and the western Atlantic will be wrung out over the northern Rockies. Southern downpours will likely worsen later next week. That is the forward-looking projection from the pattern scale forecasting consensus on the morning of May 28th. Read that summary again, slowly, because every phrase in it carries weight, and the weight compounds. Flooding risks will rise across the US into June. Slow-moving, omega block, tropical moisture from the sultry Pacific and western Atlantic, wrung out over the northern Rockies, southern downpours will likely worsen later next week. That is not a forecast for tomorrow afternoon. That is a forecast for the next 10 to 14 days, framed around a single continental atmospheric configuration that the National Weather Service has now openly named in 5 separate regional offices. So let me lay out what this video is actually about, because we're going to follow the thread carefully. The omega block sitting over the United States right now is the same pattern that, in our video from yesterday, we identified as the configuration that broke the worst drought in modern American record. That video was about the first half of what this block does. It was about how the same continental configuration that locked the country into the driest January through March in 131 years of record keeping was also the configuration that lifted the first meaningful tropical moisture surge of the year up out of the western Caribbean and across the Gulf Coast, Florida, and the southeast. The cure and the threat, we said, ride the same body of moisture. This video is about the second half, because that body of moisture is now lifting north. The same block that wrung the western Caribbean over the southeast yesterday is now about to wring the eastern Pacific and the western Atlantic over the northern Rockies this weekend, and then it is going to wring the Caribbean moisture back across the southeast next week as the block slowly de-amplifies. The drought-breaking moisture was the first phase. The continental scale flood pulse, the one the forecast consensus is summarizing in plain English this morning, is the second phase. We are not done with this block yet. We are in the middle of it. And that is the specific phrase you need to hold on to. We are in the middle of it, not the end. The middle. The structural midpoint of how long this configuration is expected to hold is happening today, Thursday, May 28th. The Weather Prediction Center is saying it locks through early next week before turning more zonal, mid to late week. That projects out to approximately Wednesday, June 4th, before the block fully releases. We are at the halfway mark. The heavy precipitation phase, the part where the moisture that the block has been lifting all week starts coming back down across the country, is still ahead of us. The flood phase has not started yet. It is forecast to begin Sunday over the northern Rockies and worsen through next week across the southeast. So when you hear someone summarize the weather right now by saying the pattern is locked, what they actually mean is that the consequence of the pattern is still unfolding. The lock is the cause, the flood is the effect, the cause is in place, the effect is the next 10 days. And here is the phrase you need to remember more than any other from this entire video. Slow moving. Because slow moving is the word that separates a weather pattern, that produces inconvenience from a weather pattern, that produces catastrophe. A weather system that moves at normal speed across the country, the way most fronts do, takes the moisture it is carrying and spreads it thinly across a wide geographic footprint. The same 50-mile wide band of rain that produces 2 inches at any one point if it moves fast, produces 6 inches if it slows down by a factor of 3, because the same band lingers over the same square mile 3 times longer. The atmosphere is doing arithmetic, and the arithmetic of stalling is brutal. Hurricane Harvey in 2017 put 51.88 inches of rain on Nederland, Texas, not because the storm carried unusual amounts of moisture, but because it stalled. The West Virginia floods of 2016 put 8 to 10 inches on the same counties in 6 hours, because the cells trained over the same pixels for 6 hours. The Tennessee floods of 2010 put 13.57 inches of rain on Nashville in 36 hours because the system did not move. You will see this phrase, slow moving, in nearly every flood catastrophe in the last 50 years that was not directly a tropical cyclone landfall. The Pennsylvania flood of 1972, when the remnants of Hurricane Agnes stalled over the Susquehanna Basin, was slow moving. The Mid-Atlantic flood of 1955, when Hurricane Diane stalled over Connecticut after Connie had already saturated the ground, was slow moving. Every single one of these events shares the same dynamical signature. The system did not move, the moisture did not stop, and the basin underneath could not handle what was being deposited on it. And the National Weather Service is using that phrase this morning. They are using it on purpose. They are using it because they want you to understand that the Omega block parked over the United States right now is, by definition and by forecast, slow moving. The trough on the west leg will close off into a broad upper low and spin over the northern Rockies. The trough on the east leg will be reinforced by several disturbances rotating around a parent trough over Atlantic Canada. The ridge in the centre will hold the warm core. None of these features will move appreciably for the next 5 to 7 days. The block is dynamically stuck. So now you understand the basic structure. There is a giant Greek letter parked across the United States. The shape of it is well defined and rare for late May. Multiple forecast offices have named it explicitly, which they do not normally do. It is forecast to hold for another week. The flood phase has not started yet, and the National Weather Service, the Weather Prediction Centre, and an independent forecaster who watches patterns at this scale have all, on the same morning, in nearly identical language, said that the consequence of this block holding through the weekend and into June is that the moisture currently being lifted into it from both oceans is going to come back down on the continent in concentrated multi-day rainfall events. But we have not gotten to the most unusual part yet. Because the most unusual thing about this configuration is not the shape itself, it is not the persistence, it is not even the timing. The most unusual thing about this configuration is which oceans are feeding it. And once you see which oceans are feeding it, you will start to understand why the forecast offices are converging on the same projection for the next 10 days, why the marginal risk areas have been drawn where they have been drawn, and why the cascade of consequences is going to keep unfolding across the country well into the first week of summer. That part of the story starts now. Part 2. Both oceans are feeding one storm. The forward-looking forecast that the moisture being wrung out over the northern Rockies this weekend is coming from both the sultry Pacific and the western Atlantic uses a phrase that probably did not register the first time you read it. Both oceans, from the sultry Pacific and the western Atlantic, not one or the other, both, into the same continental block at the same time for the same flood event. And that is the configuration that almost no other phrase in modern meteorology describes more efficiently. Both oceans, one storm. The way moisture normally moves through the atmosphere over North America is that you have a primary moisture source, and a secondary moisture source plays a supporting role. Most flood events you can name from memory are dominated by a single moisture pool. Hurricane Harvey was a Gulf of Mexico event. The northeast nor'easters are Atlantic events. The California atmospheric rivers are Pacific events. Even the Great Midwest Flood of 1993, which was a multi-week stall pattern, was dominated by Gulf moisture lifting north through the central United States with the Atlantic playing a supporting role. The atmospheric circulation over the continent is generally configured so that moisture comes from one direction at a time, even when the underlying ocean state is warm. But that is not what is happening this week. What is happening this week is that the Omega block has set up the continental circulation so that both moisture sources are simultaneously connected to the same continental airspace, and both moisture sources are being lifted into the same continental basin. The trough on the western leg of the Omega is anchored over central California. South of that trough, the circulation is drawing moisture up out of the eastern Pacific. Far to the southwest of Baja California, the National Hurricane Center is tracking a broad area of low-pressure forecast to develop early next week. The National Hurricane Center Eastern Pacific Tropical Outlook, issued at 5 in the morning, Pacific time, this morning, reads as follows. For the eastern and central North Pacific east of 180 longitude, well southwest of the Baja California Peninsula, a broad area of low pressure is forecast to form early next week well to the southwest of the southern tip of the Baja California Peninsula. Some gradual development of this system is possible. That broad area of low pressure, even if it does not formally develop into a tropical cyclone, is going to lift a substantial column of warm moist air northward into the circulation around the western leg of the Omega. That moisture, riding the southern flank of the closed upper low over California, is going to feed the precipitation event forecast for the northern Rockies this weekend. That is the Pacific contribution. But that is only half the picture, because on the other side of the continent, the eastern leg of the Omega, anchored over southeastern Canada and New England, has its own moisture transport. The Miami Forecast Office, in its area forecast discussion issued at 2:35 this morning, Eastern Time, described the Atlantic side of the configuration in detail. The consensus is for the eastern conus trough to spread further down the eastern seaboard as multiple shortwaves rotate through it. At the same time, the southern plains wave is expected to stretch and fracture into multiple sections, moving north through the northern plains, east through the deep south, and east-southeast through the southwest and south-central Gulf. All of this will help displace the western Atlantic ridge and open up a channel of tropical moisture advection from the western Caribbean into the eastern Gulf and across the state of Florida. That is the Atlantic contribution. A channel of tropical moisture advection from the western Caribbean into the eastern Gulf and across the state of Florida. The Miami office, in the same discussion, then gave us the numerical anchor. Rain chances will be on the rise with forecast PWatts in the top 10% for this time of year. Let me translate that phrase. PWatt is shorthand for precipitable water. It is a measurement of how much water is in the atmospheric column above a given point on the ground. If you took every molecule of water vapor in the column above your head and condensed it down to liquid form, how many inches deep would that liquid sit on the ground? That is precipitable water. And when the Miami office says PWatts in the top 10% for this time of year, what they are saying is that the column of water in the atmosphere over Florida this weekend is going to be among the wettest 10% of all values ever observed over Florida in late May. The atmosphere over the southeast is loading up with rare air moisture. So here is the configuration. Eastern Pacific developing low, Western Caribbean moisture pool, both connected by the circulation around the Omega Block to the same continental airspace. The Pacific moisture lifts north and east into the western leg of the block. The Caribbean moisture lifts north and west into the eastern leg of the block. Where do those two moisture streams converge? They converge inside the block. They converge over the northern Rockies first, this weekend, when the closed upper low spins up over Montana and northern Wyoming. They converge over the southeast next week, when the frontal boundary holds in place and the Caribbean stream keeps feeding into it. The same configuration. 2 streams, 2 flood pulses, 1 block. And this is the operational reason the Weather Prediction Center, the regional offices, and the public-facing pattern scale forecast consensus are all converging on the same forward-looking flood forecast. The math of 2 moisture streams into 1 continental basin produces a different precipitation outcome than the math of 1 moisture stream alone. When you have 2 simultaneous transport pathways from 2 warm tropical ocean basins, the atmosphere can sustain a much higher rate of moisture deposition over a much longer period than it could with 1 transport pathway alone. The block holds the configuration in place. The 2 oceans keep refilling the moisture pool. The flanks of the block keep depositing the moisture as it accumulates. The structural conditions for a multi-day, multi-region sustained flood event are present, and remember the baseline state of both ocean basins. The NOAA Oceanic Niño Index for the February-March-April season of 2026 just came in at plus 0.11 degrees Celsius. 3 seasons ago, in October through December of 2025, that same index was at minus 0.55. The ocean has swung positive 0.66 degrees Celsius in 3 seasons. That is a substantial energy loading of the equatorial Pacific. Subsurface temperatures at 100 meters depth are running plus 5 to 6 degrees Celsius above normal. The Pacific is sultry because it is loading up for the El Niño that the Climate Prediction Center has been issuing a watch for, and that the atmospheric scientific community has been describing in the language we covered in our video from a few days ago on the heat wave forming in the Pacific, and in our video from May 15th on the Super El Niño implication. The Atlantic is in its own state of sustained surface warmth. The multi-year North Atlantic warm anomaly that has been documented since 2023 is still in effect. The Western Caribbean and the Gulf of Mexico are running above normal for the calendar position. Both ocean basins are preloaded with elevated moisture content. The Omega Block parked over the continent has connected both of those basins to the same continental airspace. The moisture transport is therefore at high capacity from both sides simultaneously. This is not a normal configuration. This is the rare air configuration. And it is the configuration the National Weather Service is naming this morning, with the specific phrase, slow-moving Omega Block, because that phrase carries operational implications. When this configuration appears in late spring with both ocean basins running warm and the block forecast to hold for a week, the historical precedent for what happens next is unambiguous. The moisture comes back down. It comes back down progressively. It comes back down over multiple regions in sequence. And it comes back down with totals that exceed the climatological expectation for the calendar position. That is why the WPC issued marginal risks for excessive rainfall on Sunday and Monday over Montana and northern Wyoming. That is why the WPC issued marginal risks for excessive rainfall on Sunday and Monday over parts of the southeast into Florida. That is why the Miami office is calling for top decile precipitable water. That is why the Birmingham office is forecasting the frontal boundary to slowly nudge southward across Alabama over the weekend, with better rain chances Friday through Monday. That is why Houston, in its forecast issued just after 11 last night, was already calling for daily chances of showers and storms from Sunday through midweek. The forecasts have already been issued, the configuration is already in place, the moisture is already loading, and the first region the block is targeting is the one you would not necessarily expect. Part 3. The Northern Rockies are the target. This weekend. When you think about flooding in the United States, the Northern Rockies are not the first region that comes to mind. You probably think about the Gulf Coast, you probably think about the Mississippi Valley, you probably think about Houston and New Orleans and Charleston. You think about places where flat coastal land meets warm tropical ocean. You think about places where hurricanes spin in and dump their loads. You do not, generally, think about Montana and northern Wyoming. You think of Montana as fire country, as blizzard country, as big sky drought country. And yet, this weekend, the National Weather Service Weather Prediction Center has placed Montana and northern Wyoming in a marginal risk area for excessive rainfall on Sunday, with the same risk continuing into Monday, and the same risk specifically tied to a closed upper-level low spinning over the region. Let me read you the language from the WPC discussion verbatim. The trough over the west will close off into a broad upper low and spin over the northern Rockies, bringing low elevation heavy rain and mountain snow Sunday into Monday. The signal for heavy rainfall remains robust enough to maintain the day 4 Sunday marginal risk across a large portion of Montana and a part of northern Wyoming, with intensity waning heading into Monday and Tuesday. So let me unpack what is being forecast. A closed upper level low, spinning, over the northern Rockies for approximately 48 to 72 hours, producing 2 separate forms of precipitation in 2 separate elevation bands. Low elevation heavy rain in the valleys, snow in the mountains in late May. The configuration is specific, the duration is specific, the geographic footprint is specific, and every operational element of it is forecast to occur because the western leg of the Omega block has closed off into a stalled upper low that is going to sit over Montana and northern Wyoming and pull moisture northward from the eastern Pacific for 2 to 3 days straight. Now think about what spinning means in this context. A closed upper-level low is a counterclockwise rotation in the upper atmosphere. The rotation acts like a paddle wheel. It draws air upward through its center. As that air rises, it expands and cools, and the moisture in it condenses out as precipitation. If the low is moving, the precipitation falls across a long, narrow track. If the low is stationary, the precipitation falls on the same geographic footprint over and over again. The Weather Prediction Center is using the word spin, and they are using the word over, and they are using the time frame Sunday into Monday. They are telling you, in operational forecast language, that this low is not going anywhere. It is going to sit there. It is going to draw moisture up into its center for 2 to 3 days, and it is going to deposit that moisture on the ground beneath it. The terrain underneath that low is mountainous. The northern Rockies span elevations from approximately 3,000 feet in the river valleys to over 11,000 feet in the highest peaks. When moist air is forced upward by a mountain barrier, the same process that occurs in the upper-level low's rotation occurs again at the surface. The air rises, it expands, it cools. The moisture condenses out, precipitation falls. This is called orographic lift, and it is the reason mountain ranges produce more precipitation on their windward sides than on their leeward sides. The combination of an upper-level low providing dynamical forcing for ascent and a mountain range providing topographic forcing for ascent is a maximization configuration for precipitation. The two mechanisms stack, and in late May, at northern Rockies elevations, the temperature profile is such that the precipitation falls as rain in the valleys and as snow in the mountains. The freezing level in late May over the northern Rockies typically sits between 8 and 10,000 feet. Below that elevation, it rains. Above it, it snows. Both forms of water are being deposited on the same basin at the same time. The rain runs off immediately into the river systems. The snow accumulates on the high peaks. Then, when the system moves out and the temperature climbs back up the following week, the snow melts, and the meltwater enters the same river systems. The flood event therefore has a two-stage character. The rain phase happens during the storm. The melt phase happens after the storm. The river basins downstream see both pulses sequentially. The mountain snow phase is itself unusual for the calendar position. Snow events at the elevations forecast to receive snow this weekend, above 7,000 to 8,000 feet across the northern Rockies, occur in roughly 1 in every 5 years during the May 28th to June 2nd calendar window. The current forecast is for a relatively widespread event across Montana and northern Wyoming high terrain, which puts it in the upper tail of the historical distribution for the calendar position. We are not talking about a record-breaking event. We are talking about an upper quintile event, unusual but not unprecedented. The rain phase is where the flood risk is concentrated. The basins drained by the upper Missouri, the Yellowstone, the Bighorn, the Powder, the Tongue, and the Musselshell rivers are all in the geographic footprint of the forecast event. These are basins that are already running above normal in their reservoir storage from earlier snowpack runoff. Their hydrologic state is wet. Adding a 2 to 3 day precipitation event on top of an already wet basin produces faster runoff response than the same event would produce on a dry basin. The first inch of rain into a wet basin runs off. The first inch into a dry basin gets absorbed. The basins are wet. The runoff response will be quick. You should also understand the physical geography of how runoff travels through this region. The upper Missouri and its tributaries flow through narrow mountain valleys before broadening onto the plains. In the narrow valley sections, the channels are confined and the velocities are high. A flash flood in a confined mountain valley is a wall of water moving at speed. It is a different physical event from a slow-rise flood on a wide, flat river. The towns and ranches that sit in the mountain valley sections of these basins are vulnerable to the flash component. The flat valley sections downstream are vulnerable to the slow-rise component, as the runoff translates downstream over the following days. The WPC's marginal risk classification means that conditions are favourable for isolated flash flooding to occur. It is the lowest of the 4 excessive rainfall risk categories. It does not predict that flooding will definitely occur, it predicts that the conditions exist for it. But the marginal risk for Sunday is the first day of a multi-day event. The Monday risk is the continuation. The Tuesday risk is the runoff translation. The forecast period of elevated risk in the northern Rockies spans at least 3 operational days, and the WPC has explicitly stated that intensity wanes heading into Monday and Tuesday, which means that the peak rainfall is forecast for Sunday itself. Now consider what this looks like on the ground. A weekend in late May, the first holiday-adjacent weekend after Memorial Day. Recreation season is opening across the Mountain West. Memorial Day weekend just ended, and the next major holiday is still a month away, but late May is when school lets out across the western states, when families plan camping trips into the national parks, when fishing season opens, when the backcountry starts seeing visitors after the long winter. The northern Rockies tourism economy is built around exactly the weeks the closed upper low is going to spin over. Visitors who planned trips months in advance for the late May weekend are going to find themselves underneath a stalled atmospheric system, depositing heavy rain on the valley floors and snow at the higher elevations they were planning to hike. The fire weather agencies that were watching the eastern flanks of the Omega for critical fire conditions earlier this week are watching the same flanks for flash flood potential by Sunday. The same atmospheric configuration that was setting up red flag warnings in southern Utah on Wednesday is the configuration that is going to ring rain out over Montana on Sunday. The same wave, the same block, different face, different geography, different consequence, and the moisture being wrung out over the northern Rockies is, as we covered in the previous part, a combination of eastern Pacific moisture pulled north by the closed upper low and Caribbean moisture pulled around the broader block circulation. The two streams have been transporting moisture into the configuration all week. The closed upper low is the ringing mechanism. The northern Rockies are the ringing target. Sunday is the ringing day, so if you live in Montana or northern Wyoming, or any of the river valley communities downstream of the high terrain in this region, the operational message is straightforward. Watch the forecast through Saturday. The first signs of organised convection moving into the region will arrive Friday into Saturday as the upper low closes off. The peak rainfall is Sunday. The flash flood risk is highest Sunday afternoon and evening, when the strongest dynamical forcing for ascent coincides with the warmest part of the day and the highest moisture content. The runoff translation downstream continues Monday into Tuesday. By Wednesday, the system begins to release. The runoff response in the basin systems will translate downstream over the following several days. The Missouri River below the confluence with the Yellowstone runs through a flat, broad floodplain where the runoff translation produces slow rises rather than flash events. The Yellowstone itself, draining the eastern slope of the greater Yellowstone ecosystem, and the Beartooth Absaroka complex, will see the most concentrated runoff pulse from the high elevation snow phase as that snow melts in the days following the storm. The combined inflow into the Missouri at the confluence near Sidney, Montana, will produce a sustained elevated flow that propagates downstream into North Dakota and then into the lower Missouri basin through the first half of June. The flood translation timescale for the Missouri from headwaters to lower basin is approximately 10 to 14 days. The storm this weekend, therefore, will continue producing observable hydrologic responses in basins hundreds of miles from the storm itself for the next 2 weeks. This is the part of the flood story that the public communication often misses. The storm is a 4-day event. The flood translation through the river systems is a 2-week event. The maximum hourly rainfall happens on Sunday and Monday. The river crests in the lower basin happen the following week. The communities sitting along the lower river systems will be watching the gauges rise through the second week of June for water that fell as rain in Montana on Sunday. The Yellowstone watershed in particular contains several flood-prone communities downstream of the high-terrain target zone. Billings, Montana, sits at the bottom of the Yellowstone-Clarks Fork confluence, and historical flood events have produced significant urban impacts there. Glendive sits further downstream. The combined Missouri-Yellowstone flow proceeds through North Dakota near Williston, where the Garrison Reservoir provides some attenuation, but where high inflow events still propagate. The reservoir operators in the basin will be watching the storm event closely and adjusting outflow rates to manage the downstream response. The northern Wyoming portion of the marginal risk area covers the Bighorn and Powder River basins, which drain into the Yellowstone from the south. These basins sit in the rain shadow of the Bighorn Mountains and historically receive less precipitation than the western slopes. But a closed upper low with both ocean moisture feed can override the typical rain shadow effect by drawing in moisture from a different direction. The Bighorn Basin towns of Graybull, Worland and Thermopolis sit along the river with established flood history. The Powder River Basin towns of Sheridan and Buffalo sit upstream of confluences where the runoff response is concentrated. This is what the marginal risk area means in concrete geographic terms. It is not an abstract square on a map. It is a specific set of mountain basins, a specific set of river systems, and a specific set of communities sitting downstream of where the heaviest rain is forecast to fall. Every one of those communities has a flood history. Every one of those communities has emergency management infrastructure that has been preparing for the forecast through the week. The marginal risk classification is the operational signal that those preparations should continue into Saturday and Sunday as the storm approaches, and the storm approach itself will have an observable signature in the forecast products available to the public. The closed upper low forecast to develop over the region this weekend is already visible in the model output as an upper-level circulation feature. As the feature consolidates from Friday into Saturday, the model run-to-run consistency on the timing and the rainfall placement will increase. By Saturday afternoon, the storm will be operationally close enough that the high-resolution short-range models will be providing detailed quantitative precipitation forecasts that emergency managers can use for specific staging decisions. The transition from the 7-day pattern-scale forecast we are describing today to the 12 to 36-hour mesoscale forecast that will drive the Sunday response is the standard forecast progression. The communities in the marginal risk zone should expect, between now and Sunday afternoon, an escalating sequence of forecast products. Today, the Day 4 marginal risk. Friday, the Day 3 update with refined geographic detail. Saturday morning, the Day 2 outlook with potential upgrade to slight risk if the model consensus tightens around the heaviest rainfall band. Saturday afternoon, the Day 1 outlook with concrete hourly rainfall rate forecasts. Sunday morning, the active event nowcast products with radar trends and short fuse warning sequences. Each step of that sequence is the forecast system narrowing the uncertainty as the event approaches. The marginal risk we see today is the first signal in the sequence, but the northern Rockies are only the first target. The block holds, the moisture keeps loading, the configuration shifts, and by the middle of next week the same atmospheric pattern that is ringing out the northern Rockies this weekend will be ringing out a different region of the country. A region that, unlike the northern Rockies, is already saturated. a region where the ground cannot absorb what is about to be deposited on it. Part 4. The southeast is already flooded, and it's going to get worse. If you have been following the weather across the southern United States for the last several weeks, you already know what the ground looks like. It looks wet. It looks soaked. It looks like a basin that has been receiving rain pulse after rain pulse for the better part of a month. The river systems across the Gulf Coast and the Ohio Valley have been running at flood stage in various sections for weeks. The soil moisture in the upper layer of the ground across most of the southeast is at or near saturation. The reservoirs are full. The retention ponds are full. The drainage systems in the urban areas are running at capacity. And as of this morning, Thursday, May 28, 2026, the National Weather Service has 30 flood warnings currently in force across the country. 30. And 2 separate flash flood warnings active right now in eastern Tennessee. And it has not even rained yet from the configuration we're about to describe. Let me give you the specifics so you can see the scale. The flash flood warnings are for Cock County and Greene County in East Tennessee. The National Weather Service in Morristown extended the warning at 10:44 in the morning Eastern Time, after local law enforcement reported flooding across the warned area. Between 2 and 4 inches of rain had fallen as of the report. Flooding impacts will continue, but no additional rainfall is expected from the current event. That is from a system that has already moved through. The rain has already fallen. The flooding is already happening, and the warning is still in place because the runoff is still translating. The 30 active flood warnings span a wide geographic footprint. The Scioto River at Circleville, Ohio. The South Fork Licking River near Buckeye Lake, Ohio. The Driftwood River near Edinburgh, Indiana. The East Fork White River at Seymour, Indiana. The Pearl River near Pearl River, Louisiana and Mississippi, where the warning extends until Sunday morning. The Pearl River above Philadelphia, Mississippi. The Pascagoula River at Merrill, Mississippi. The Leaf River near McLean, Mississippi, where the warning extends until early Sunday. The Chickasaw River at Leakesville, Mississippi. The Wolf River above Gulfport, Mississippi. The Tombigbee River near Coffeyville Dam, Alabama. The Tombigbee River near Leroy, Alabama. The Calcasieu River near White Oak Park, Louisiana, where the warning extends until Sunday evening. The Aransas River near Skidmore, Texas. The Nueces River near Bluntzer, Texas. The Tres Palacios River near Midfield, Texas. The Copano Creek near Refugio, Texas. The Oso Creek near Corpus Christi, Texas, where moderate flooding is forecast. The San Bernard River near Bowling, Texas. The West Fork River above Clarksburg, West Virginia. Every one of those rivers is currently in active flood status. Every one of those river basins is currently absorbing the second derivative load of a multi-week wet pattern across the southeast that has been depositing rain on the ground faster than the ground could shed it. And the omega block that we have been describing for the last 20 minutes is about to deposit another, larger, longer duration moisture pulse on top of all of it. The Weather Prediction Center, in its national discussion, addressed this directly. A very warm, humid and unstable air mass south of a wavy frontal boundary will keep much of the south and southeast active with daily rain and thunderstorm chances from late weekend into early next week. The potential for scattered clusters of thunderstorms containing high rainfall rates, combined with what has already been a wet pattern across this region, indicates that isolated flash flooding could be a concern, particularly for flood-prone areas. As a result, for Day 4 Sunday and Day 5 Monday, marginal risk areas have been introduced for parts of the southeast into Florida, combined with what has already been a wet pattern. That phrase is the operative one. The WPC is explicitly naming the antecedent saturation as a flood amplification factor. The ground is wet. The basins are full. The first inch of new rain into a system that is already at field capacity does not get absorbed. It runs off. And when you have multi-day precipitation events depositing several inches on top of a system that is already running off, the river response is fast and the flood response is amplified. The frontal boundary that is going to drive the precipitation events across the southeast through this weekend and into next week is what the WPC is calling a wavy frontal boundary. That phrase carries operational meaning. A wavy frontal boundary is a boundary that is not in a straight line. It bends and curves and breaks into segments. The bends in the boundary become focal points for convective initiation. Storms form preferentially along the bends. The bends do not move much, because the steering flow above them is the slow-moving omega block. So storms form along the bends stay in place, The next batch of storms forms along the same bends. The storms train over the same pixels hour after hour, day after day. The Birmingham, Alabama Forecast Office issued its area forecast discussion at 6:13 this morning. Let me read you what they said about this weekend, because it captures the configuration cleanly. The wet pattern continues thanks to a southerly flow both in the lower levels and the upper levels. In the lower levels, surface ridging is situated eastward off the coast from the Carolinas to Florida, with onshore flow around it into Alabama. At the same time, in the upper levels, Alabama is caught in between a ridge from Florida southeastward, a large low over California, with a protruding shortwave from it over Texas into the southern plains, and again with southerly flow in between over Alabama. We are currently in another overnight lull, with Thursday expected to be another day of diurnally enhanced elevated rain chances for the afternoon, with no organised focus. On Thursday, the latest guidance indicates that ridging will break down over Florida into the western Atlantic coast. More upper disturbances will start to meander across the deep south, from shortwave activity ejecting toward Alabama, from the California main low through the flow. Upper flow will transition on Friday night to a more west-northwest flow, as the upper low weakens and moves northeast over the northern Rockies. Ridging expands northward, some from Mexico and the western Gulf, and a second large low feature cycles over eastern Canada, the Great Lakes, and New England. It will allow for a surface frontal boundary to nudge into the far northern portions of Alabama Friday and slowly nudge southward across the state over the weekend. All of this change will result in even better rain chances for Friday through Monday, with the focus of the frontal boundary. Read that whole passage carefully because every clause carries weight. Southerly flow, both levels, surface ridge offshore Carolinas to Florida, onshore flow into Alabama, upper level ridge southeast of Florida, California low to the west, southerly flow in between, frontal boundary nudging southward through the weekend. Better rain chances Friday through Monday with the focus of the frontal boundary. That is the Birmingham office, on a Thursday morning in late May, describing the next 4 days of weather across central Alabama as defined by a slowly southward translating frontal boundary inside a continental omega block configuration that is sucking moisture northward from both ocean basins. The Miami Forecast Office described the Atlantic moisture transport in even more specific terms. The transition to westerly flow would favour convection initiating across the interior and moving to the east coast each afternoon and evening. Mesoscale boundaries and outflow from upstream convection and MCSs may disrupt that more predictable pattern. Nonetheless, rain chances will be on the rise with forecast PWatts in the top 10% for this time of year. The high PWatts also bring the potential for heavy rainfall in storms that develop. Thus, the WPC has outlooked the eastern half of South Florida in a marginal risk for excessive rainfall today. The risk for isolated flooding concerns is highest today of the coming days, as flow transitions from easterly to westerly. The southerly low-level flow and more westerly flow aloft could result in training or slow-moving storms as the sea breezes eventually collide and drift eastward. There is the phrase again, training or slow-moving storms. The Miami office is explicitly naming the training mechanism as part of the Florida flood risk this weekend. Convection initiates over the interior in the afternoon. Westerly flow steers it toward the east coast. Sea breeze boundaries collide with the outflow. The collisions stall the cells. The cells train over the same pixels for hours. The hourly rainfall rates are high. The total accumulations build. The runoff response is fast because the ground is already saturated. The top 10th percentile precipitable water value the Miami office is forecasting is operationally significant. Top decile PWatt correlates strongly with maximum hourly rainfall rates in convective events. In the southeastern climatology, the conditional probability of 3-inch per hour or greater rainfall rates increases by approximately 30 to 40% under top decile PWatt conditions. That is the difference between getting a thunderstorm that drops half an inch of rain in 20 minutes and one that drops 3 inches of rain in an hour. The first is an inconvenience, the second is a flash flood emergency. And we covered exactly this physics in our video from a few days ago on what a perfect storm flood event over a major city would actually look like. The same mechanism, saturated antecedent ground, stalled storms, top decile precipitable water, the amplification of every individual rainfall event by the cumulative state of the underlying basin. The video focused on the urban resilience and infrastructure layer. This video focuses on the regional pattern layer, but the physics is the same physics. The saturated ground in the southeast right now is the same kind of precondition that produces the worst urban flooding events in the historical record when the right storm hits the wrong basin at the wrong time. The forward look from the Weather Prediction Center is that the marginal risk areas for the southeast into Florida begin Sunday and continue Monday. The Birmingham office is forecasting better rain chances Friday through Monday. The Houston office is forecasting daily rain chances Sunday through midweek. The Miami office is forecasting the highest isolated flooding risk today and continuing through the weekend. Every regional office along the Gulf Coast, the Southeast, and the lower Mississippi Valley is converging on the same forecast. Rain, daily, for days, into a region that is already at saturation, and the second moisture pulse, the one forecast to worsen later next week, is going to fall on a basin that, by next week, has not had any meaningful drying interval. The pulse this weekend will saturate further. The pulse next week will hit ground that cannot shed it. The flood response in the river systems will compound. The flood warnings already in place will be extended, new warnings will be issued, the downstream flood translation across the lower Mississippi, the Pearl, the Pascagoula, the Tombigbee, the Apalachicola, and the lower portions of every river draining into the Gulf will continue building for weeks after the pulse itself ends. Let me give you a sense of what the saturated ground amplification actually looks like in physical terms, because the abstract phrase undersells the mechanism. When the soil column is at field capacity, the pores between soil particles are already full of water. There is no available storage space for the next pulse of rainfall. The first centimetre of new precipitation translates almost directly into surface runoff. The first centimetre into a dry basin gets absorbed. The first centimetre into a wet basin enters the stream system immediately. The mathematical translation is what hydrologists call the runoff coefficient. In dry conditions, the runoff coefficient might be in the range of 0.1 to 0.2, meaning that 10 to 20% of rainfall reaches the stream system. In saturated conditions, the runoff coefficient can rise to 0.7 or 0.8 or higher, meaning that 70 to 80% of rainfall reaches the stream system. The same precipitation event therefore produces 3 to 4 times the streamflow response on saturated ground that it would produce on dry ground. This is the multiplier. This is why the Weather Prediction Center is explicitly invoking the antecedent wet pattern as a flood amplification factor in its national discussion. The marginal risk areas they have drawn for the southeast on Sunday and Monday are calibrated against the assumption that the basins underneath are at or near saturation. If those basins were dry, the same rainfall forecast would produce a slight risk or no risk at all. The fact that the saturation is already in place is what elevates the operational concern to the level of formal probabilistic outlook. The forecast pulse this weekend will deposit additional moisture on basins that are already running off. The second pulse next week will deposit additional moisture on basins that are still running off from the weekend pulse and have had no meaningful drying interval. The compounded response in the lower river systems will be substantial. The Pearl, the Pascagoula, the Tombigbee, the Mobile, the Apalachicola, the Suwannee, the St. Johns, every major drainage system across the Gulf Coast and Florida is in the geographic footprint of the configuration. Each of those river systems will be processing additional inflow through the first and second weeks of June. The peak crests in the lower river systems are typically reached several days to a week after the most concentrated rainfall pulse, because the runoff has to translate downstream through the river system itself. The lower Mississippi River, which receives drainage from a huge portion of the central United States, has flood translation times measured in weeks. The lower portions of the smaller Gulf Coast rivers translate faster, typically 2 to 5 days. The Florida rivers translate fastest because the gradient is shallow and the channels are short, with peak responses sometimes within 24 hours of the rainfall event itself. Each timescale will produce a different flood signature in different communities along the coast. And we covered the underlying physics of this kind of compound flood event in our video from a few days ago on what a hypothetical perfect storm flood would do to a major American city. That video focused on New York City and the compound risk of surge plus rainfall, and it walked through the historical examples of the 1821 Manhattan flood, Hurricane Sandy in 2012 and Hurricane Ida in 2021. The mechanism we walked through there, where antecedent saturation amplifies subsequent rainfall events, and where the combination of surge and inland precipitation produces compound flooding that exceeds the individual hazard models applies in modified form to what we are watching across the southeast right now. The surge component is absent because there is no tropical cyclone. The rainfall component is amplified because there are 2 consecutive pulses on saturated ground. The compound nature is similar. The historical reference class is the same set of multi-day rainfall events on already wet basins that have produced major flooding throughout American hydrologic history. The specific operational threat in the next 10 days is that the second moisture pulse, the one the forecast consensus expects to worsen later next week, hits ground that has been saturated continuously since the previous weekend. The basins will be at or near field capacity through the entire forecast period. There will be no drying interval. The runoff response to the second pulse will be even more amplified than the response to the first pulse, because the soil column will have lost any residual buffering capacity. The total flood translation through the river systems by the end of the first week of June could be substantial in the lower reaches. Communities sitting in the lower elevation flood-prone zones of these river systems should treat the next 10 days as a sustained elevated risk period. The active warnings already in place are not the worst of what is coming. They are the baseline. The pulses from the Omega block will add to the baseline. The flood translation in the lower river systems will respond. Emergency managers in the Gulf Coast and the southeast will be operating in continuous escalated response mode for the duration of the configuration. This is not a one-day event. This is a multi-week unfolding, and it is being driven end-to-end by a single continental Omega block holding in place for the next 7 to 10 days. We have to talk now about why that block is holding, and why slow-moving is not just a description, but the entire mechanism. Because once you understand why slow-moving patterns produce the floods they produce, you will understand why the National Weather Service is naming this configuration in 5 separate offices on the same morning. Part 5. Why slow-moving is the whole story. There is a piece of arithmetic at the heart of every catastrophic flood event in modern American history that has nothing to do with how much moisture is in the atmosphere, and everything to do with how long that moisture sits over the same square mile. The arithmetic is brutal in its simplicity. The total rainfall at any single point on the ground equals the rainfall rate multiplied by the duration. If the rainfall rate is 1 inch per hour and the duration is 3 hours, the total is 3 inches. If the rainfall rate is 1 inch per hour and the duration is 12 hours, the total is 12 inches. The atmospheric column is doing the same work in both cases. It is the duration that quadruples. Now consider what duration means in the context of a normal weather system. A typical front moves across the United States from west to east at around 20 to 30 miles per hour. If a thunderstorm complex sits along that front and the storm is 50 miles wide along its direction of travel, the storm passes over any single point on the ground in about 2 hours. The point receives whatever the rainfall rate was for those 2 hours, maybe 1 inch, maybe 2 inches. The system moves on. The next storm in the sequence is hours or days behind. The basin underneath has time to absorb, to translate, to recover. Now consider what happens when the steering flow stops, when the polar jet, which is what drives the west-to-east translation of weather systems, slows down, when a blocking pattern sets up that prevents the normal eastward progression. The storms that form along the front now stay in place. The same 50-mile wide storm complex, instead of passing over the point in 2 hours, sits over the point for 4 hours, 6 hours, 12 hours. The rainfall rate may not have changed at all, but the duration has multiplied, and the total has multiplied with it. The same atmosphere that was going to deposit 2 inches deposits 12. This is the entire mechanism. This is why the National Weather Service is using the phrase slow-moving this week. This is why the public-facing pattern summary opened with the same phrase. They are not describing the speed of the wind. They are not describing the speed of any individual storm. They are describing the speed of the steering flow that determines how long each storm stays over each point on the ground, and the historical record is unambiguous about what happens when the steering flow stops. Let me walk you through the most catastrophic American flood events of the last 50 years that were not directly caused by hurricane landfall winds. In every single case, the proximate dynamical cause was a stalled steering pattern. Hurricane Harvey, August 2017, Texas. The storm made landfall as a Category 4 hurricane near Rockport on August 25th, and then stalled in place over southeast Texas for 4 days. The eye drifted offshore, drifted back inland, drifted offshore again, and the entire time the storm was depositing tropical rainfall on the same metropolitan footprint, hour after hour after hour. Nederland, Texas, recorded 51.88 inches of rain over the storm's duration. That is the all-time United States rainfall record from a single tropical cyclone. The storm did not have unusual moisture content. What the storm had was duration. It stalled. The steering flow had collapsed. The block over the Gulf would not release it. Houston flooded. The West Virginia floods, June 2016. A line of training thunderstorms set up over the same Appalachian counties for 6 hours. The cells trained over the same pixels because the upper-level steering flow had stalled. 8 to 10 inches of rain fell in 6 hours. 23 people died. Hundreds of homes were destroyed. The proximate cause was not the moisture content of any individual storm. The proximate cause was that the same storm formed in the same place 6 times in 6 hours, because the flow above it had stopped. The Tennessee floods, May 2010. A stationary frontal boundary draped across central Tennessee for 36 hours. Cells trained along the boundary. Nashville received 13.57 inches of rain in 36 hours. The Cumberland River rose to 47 feet above flood stage. 26 people died. The proximate cause was the frontal boundary did not move. The mid-Atlantic floods of 1972, when the remnants of Hurricane Agnes stalled over the Susquehanna River basin in Pennsylvania for 5 days. 218 people died. The Susquehanna Basin received the second largest flood event in its recorded history. The proximate cause was that Agnes stalled. The Connecticut floods of 1955, when Hurricane Diane stalled over Connecticut after Hurricane Connie had saturated the ground the week before. 200 people died. The proximate cause was the combination of antecedent saturation from Connie and the stalled steering flow that held Diane in place. The Big Thompson Canyon flood of July 1976, when a slow-moving thunderstorm complex stalled over a narrow Colorado canyon for 4 hours. 144 people died in a flash flood that moved through the canyon at 30 feet of vertical rise in 15 minutes. The proximate cause was the thunderstorm did not move. Every single one of these events, the same dynamical signature, the system stalled, the moisture kept falling on the same square mile, the ground could not absorb what was being deposited. The flood event was generated not by extraordinary moisture content, but by extraordinary duration. And this is the operational reason the phrase slow-moving carries such weight in the forecast discussions this morning. The National Weather Service is not describing the speed of the wind at the surface. They are describing the speed of the steering pattern aloft. They are describing the rate at which the configuration of the atmosphere will translate eastward across the continent. And they are forecasting that the rate is going to be approximately 0 for the next 5 to 7 days. The omega block is the steering pattern. The omega block is what is not moving. The closed upper low over central California is the western leg of the omega, and it is not translating. The closed upper low over southeastern Canada is the eastern leg of the omega, and it is not translating. The ridge of warmth in the middle is not translating. Every component of the synoptic scale circulation over the United States is stuck in place. The storms that form underneath those components, on the frontal boundaries that lie along the flanks of the omega, will inherit the stuckness. They will train, they will stall, they will deposit their moisture columns on the same square miles for hours and days at a time. And the moisture that is available to those storms is not the normal amount. It is the both ocean feed configuration we covered in Part 2. The Eastern Pacific is feeding moisture into the western leg. The Caribbean is feeding moisture into the eastern leg. The atmosphere over the continent is therefore loaded with more total moisture than a typical late May configuration would carry. Top decile precipitable water values over Florida. Above normal moisture columns up the western leg into the northern Rockies. The same total moisture, more of it available, multiplied by the same duration mechanism that produced every flood event I just walked you through. This is the math. And it is the math that explains why the Weather Prediction Center is issuing marginal risks for excessive rainfall on Sunday and Monday, over both the northern Rockies and the southeast simultaneously. And it is the math that explains why the Birmingham office is forecasting better rain chances Friday through Monday with the focus of the frontal boundary. And it is the math that explains why Miami is forecasting top 10th percentile precipitable water. And it is the math that explains why Houston is forecasting daily rain chances through midweek. The forecast offices are not guessing. They are not being alarmist. They are doing the operational arithmetic of duration multiplied by precipitable water over a defined geographic footprint, and they are getting an answer that they have to communicate to the public through the marginal risk system, the area forecast discussion system, and the public-facing alert structure. The answer they are getting, in the aggregate across the continent, is that the next 10 days are going to deposit substantially more precipitation across multiple regions than the climatological expectation. Some of that precipitation will arrive in concentrated events that exceed the capacity of the basin underneath. Some of those events will produce flash flooding. The events are not certainties at any single point, but the conditions that produce them are present at multiple points along the flanks of the block. There is one more piece of the slow-moving arithmetic worth understanding, because it explains why even individual thunderstorms underneath a stalled steering flow behave differently than they would under normal flow. Individual convective storms develop and dissipate on timescales of 30 minutes to a few hours. Under normal steering, a thunderstorm forms, moves with the flow, dumps its load along a translation track, and dissipates as the supporting atmospheric conditions move on. The next storm forms in a different geographic position because the conditions have moved with the flow. The net effect on any single point is that the rainfall from any individual storm is constrained. Under stalled steering, the supporting atmospheric conditions do not move. The first storm forms, moves with whatever weak local flow exists, dumps its load, dissipates. The second storm forms in approximately the same position because the supporting conditions did not move. The second storm follows approximately the same track. The third storm forms in approximately the same position. The same point on the ground gets hit by 3 storms instead of 1. This is called training, and the geographic signature of training shows up as long, narrow, repeated rainfall bands aligned with the slow local flow. The cells train along the band like train cars along a track, each one depositing its load on the same set of pixels. The training mechanism has been documented in the meteorological literature for decades. It is the proximate cause of nearly every flash flood disaster that occurred in the absence of a tropical cyclone or an extreme atmospheric river. The Tennessee floods of 2010 happened because cells trained along a stationary frontal boundary. The West Virginia floods of 2016 happened because cells trained along a similar boundary. The Iowa floods of 2016 happened because cells trained along a plains boundary. The Texas Hill Country flood of 1987, the Houston floods of 2015 and 2016, the Ellicott City, Maryland flash floods of 2016 and 2018, the Waverly, Tennessee flood of 2021. Every one of these events had training as the proximate dynamical cause. Cells formed in the same place over and over because the steering flow above them was stalled. The slow-moving omega block we are watching this week is the kind of steering pattern that produces training events along its flanks. The frontal boundaries that lie along the western leg of the omega over the northern Rockies are the boundaries along which cells will train this weekend. The frontal boundary draped across the southeast next week is the boundary along which cells will train then. The training mechanism is exactly what the Miami Forecast Office is naming when they write about training or slow-moving storms in the Florida coastal sea breeze convergence zones today. The mechanism is operationally active across multiple regions of the country simultaneously, because the block is producing the stalled steering everywhere along its structure. This is why a single continental synoptic configuration can produce multiple flash flood events in widely separated geographic regions on the same calendar weekend. The mechanism is the same mechanism, the boundary is different, the cells are different, the training is identical in its dynamical signature. The block is the cause, the training is the immediate process, the flood is the outcome. And every one of those conditions traces back to the same root mechanism. The block is not moving. The pattern is slow, the moisture sits, the duration multiplies, the arithmetic is brutal. Part 6. Why the atmosphere is locking. We have spent the last 40 minutes describing what the omega block is doing. We have not yet asked why it is there in the first place. And the answer to that question is one of the genuinely interesting and partially unsettled stories in modern atmospheric science. Because the frequency of blocking patterns in the mid-latitudes appears to be increasing, the phase speed of the polar jet stream appears to be decreasing, and the geometry of the waves in the jet appears to be amplifying, all on a timescale that overlaps with the documented warming of the Arctic. The question of why is therefore a question with current scientific dispute layered on top of a basic dynamical understanding that is, at this point, settled. Let me give you the settled part first. The polar jet stream, which is the river of fast-moving air at roughly 30,000 feet that drives most mid-latitude weather across the United States, is fundamentally a temperature gradient phenomenon. The cold polar air to the north and the warm tropical air to the south create a temperature contrast. The atmospheric pressure responds to that contrast. The wind flows along the boundary. The strength of the wind and the smoothness of its flow depend on how steep the temperature gradient is. A strong gradient produces a strong jet. A strong jet runs in a relatively zonal, west to east pattern with small waves in it. Weather systems form along the jet and translate eastward briskly. The continent sees rapid succession of fronts. The atmosphere flushes itself out. A weak gradient produces a weak jet. A weak jet meanders. The waves in it grow larger in amplitude and slower in phase speed. The waves can stall. Blocking patterns form, weather systems get stuck. The continent sees the same pattern for days or weeks at a time. The arithmetic of duration that we covered in the previous part starts running long. That much is undisputed. The argument that has been ongoing in the peer-reviewed literature for the better part of a decade is about whether the gradient is actually weakening on a climatologically significant timescale, and if so, whether the documented warming of the Arctic is the proximate driver of the weakening. The most recent peer-reviewed assessment of Arctic warming rates came from Rantanen and colleagues in 2022, published in Communications, Earth and Environment. The title of their paper was "The Arctic has warmed nearly 4 times faster than the globe since 1979. 4 times faster." The paper used multiple observational records and reanalysis datasets to confirm what other groups had been measuring with smaller multipliers in earlier work. The Arctic is warming. It is warming substantially faster than the global average. That is a settled observation. The next question, raised most influentially by Jennifer Francis and Stephen Vavris in a 2012 paper in Geophysical Research Letters, was whether this faster Arctic warming, by compressing the equator to pole temperature contrast, was producing a measurably wavier polar jet stream already. Their answer was yes. Their evidence was that the amplitude of the waves in the upper-level circulation, measured by a metric called meridional flow index, had increased over the satellite era. Their conclusion was that the increase was driven by Arctic amplification, and that the consequence was an increase in the frequency of mid-latitude blocking patterns and the extreme weather they produce. The Francis-Vavris hypothesis triggered roughly a decade of follow-up work. Some studies confirmed and extended their findings. Other studies challenged the magnitude or the attribution. Elizabeth Barnes in 2013 pointed out methodological sensitivities in the original measurement. James Screen and Ian Simmons in 2013 examined the seasonal variation of the signal. Dim Kumo and colleagues in 2014 extended the analysis using a different statistical framework and found evidence for what they called quasi-resonant amplification of certain wave numbers, particularly wave number 5 and wave number 7, which correspond to specific large-scale wave patterns in the Northern Hemisphere. Kai Kornhuber and colleagues in 2020, publishing in Nature Climate Change, demonstrated that the quasi-resonant amplification of wave number 5 and wave number 7 patterns produces up to 20 times the concurrent extreme heat probability across distant regions of the same hemisphere. The work that connects most directly to what we are watching today came from Hahn and colleagues in 2021, publishing in Water Resources Research. They examined what they called low-phase speed Rossby wave packets, which is the mathematical descriptor of slow-moving large-amplitude waves, and they demonstrated that those packets are the proximate driver of persistent regional drought and persistent regional precipitation, depending on which side of the wave a region sits on. That Hahn 2021 finding is essentially the technical translation of what the pattern scale forecast is saying in plain English this morning. A slow-moving omega block pattern is, in the language of the academic literature, a low-phase speed wave packet. The persistent regional precipitation it produces on the wet sides is what the forecast is calling for over the northern Rockies and the southeast. The persistent regional drought it produces on the dry sides is what was driving the wildfire and red flag conditions on the ridge over the Central Plains earlier this week. The same wave produces both. The Hahn paper is the operational physics. The public-facing forecast is the operational translation. They are describing the same phenomenon at different levels of abstraction. The peer-reviewed consensus as of 2026 is that Arctic amplification is contributing to a measurable increase in the frequency of mid-latitude blocking events, with the strongest signal in summer when the meridional temperature gradient is naturally weakest. The dispute is over magnitude. Some papers project a large increase in blocking frequency over the coming decades. Others project a more modest increase. The dispute is not over the existence of the mechanism. The dispute is over the rate of its amplification. What this means for the omega block we are watching this week is that the configuration is, in part, an expression of a long-term trend that the climate system is in the middle of. It is not the only cause. The atmosphere produces blocking patterns in every year of the historical record. Late May blocks of this clarity are documented in roughly 10 to 15% of late May calendar windows in the post-1979 reanalysis baseline. The current configuration is at the high end of clarity for the calendar position. Whether it represents one expression of a long-term increasing trend, or whether it represents a particularly clean expression of a configuration that has always occurred occasionally in late May, is a question that any single event cannot answer. But the cumulative weight of the peer-reviewed literature suggests that the frequency of these events has been increasing, and that the rate of increase tracks the rate of Arctic warming. Now let me bring in two additional pieces of physics that matter for understanding why the current configuration carries the moisture load it is carrying. The first is the soil moisture atmosphere coupling mechanism documented by Diego Miralles and colleagues in 2019, publishing in the Proceedings of the National Academy of Sciences. The Miralles paper demonstrated that drought-primed soils produce disproportionate runoff and flash flood risk under subsequent heavy precipitation events through a process of reduced infiltration capacity and accelerated overland flow generation. The same paper documented that soil moisture atmosphere coupling increases extreme heat likelihood by approximately 30% under drought conditions. What that means is that the heat side of this same block, the part producing 92 degrees in Bismarck and 101 degree feels-like temperatures in Montana, is being amplified by the dry soil mechanism on the central ridge, while the flood risk on the flanks is being amplified by the saturated soil mechanism on the western leg and the eastern leg. The same paper, the same mechanism, working in opposite directions across the geographic flanks of the same block. The second piece of additional physics is the aerosol unmasking hypothesis advanced by James Hansen and colleagues in 2023, publishing in Communications, Earth and Environment. Hansen and his co-authors proposed that the implementation of the 2020 International Maritime Organization sulfur cap regulations removed approximately 80% of sulfate aerosol emissions from international shipping, which had been masking approximately 0.05 degrees Celsius of underlying greenhouse warming. The removal of the mask, their hypothesis argues, is producing a documented acceleration in global mean surface temperature from 2023 onward that is not yet fully captured in the climate model projections used in the most recent international assessments. The peer-reviewed counterview was advanced by Quaglia and Visioni in 2025, publishing in Atmospheric Chemistry and Physics, arguing that the aerosol effect is smaller in magnitude. The Hansen view and the Quaglia counterview are both legitimate positions in the current scientific literature. The point for our purposes is that the elevated baseline state of both the Eastern Pacific and the Atlantic that we are watching this week, the state the public-facing forecasts have been describing with the word sultry, is in some fraction attributable to a recent step change in aerosol forcing in addition to the long-term greenhouse warming trend. The block parked over the continent today is therefore sitting in a state where the moisture available to it is, in part, a function of policy changes made for shipping emissions in 2020. That is the dynamical context. Arctic amplification is slowing the polar jet. The slower jet produces larger, slower-moving waves. The waves stall more often, producing more frequent blocking patterns. The blocks transport moisture into specific geographic targets through their flanks. The moisture available to those flanks is loaded by warm ocean basins that are themselves running warmer than baseline. The soil moisture state on the ground amplifies the precipitation to flood translation. The aerosol unmasking adds an acceleration to the warm baseline. Every one of these mechanisms is documented in the peer-reviewed literature. Every one of them is operating right now, on the omega block we are watching, in the way the physics says it should operate. And there is one more piece of the dynamical context worth giving you, because it explains why the configuration we are watching this week shares its underlying machinery with several configurations we have covered on this channel in recent weeks. The Han 2021 paper on low-phase speed Rossby wave packets is the most directly applicable peer-reviewed framework for understanding what is happening this week. The authors examined the statistical properties of slow-moving wave packets in the Northern Hemisphere mid-latitude circulation, and demonstrated that the packets cluster preferentially in certain geographic positions and certain seasonal windows. The packets are not random, they form preferentially under specific underlying ocean states. They form preferentially under specific Arctic temperature configurations. They form preferentially in seasonal windows where the gradient is weakening or weakened. Late May is one of those seasonal windows. The gradient is weakening rapidly as the Arctic loses its winter cold reservoir. The ocean states are loaded with the multi-month accumulated heat from the spring transition. The packets that the underlying atmospheric dynamics produce in late May have a higher probability of being slow-moving than the same packets in February or March. The configuration we are watching this week is therefore, in a statistical sense, a late May expression of a mechanism the climate system has been making more common over the satellite era. The Kornhuber 2020 Nature Climate Change paper extended the framework by demonstrating that the quasi-resonant amplification mechanism produces concurrent extreme heat across distant regions of the same hemisphere. The mechanism described in the paper is that when a stable wave pattern locks in, the ridges in the pattern simultaneously produce heat anomalies in geographically separated regions, and the troughs in the pattern simultaneously produce cool or wet anomalies in different separated regions. The pattern is not localized, it is hemispheric. And we have been documenting on this channel for 2 months that the same general framework is producing simultaneous heat anomalies across Europe, the United Kingdom, India, and now the northern plains of the United States, all in the same several-week window. The Met Office attribution analysis on the United Kingdom's all-time May temperature record this week framed the event as roughly 3 times more likely under the current climate than under a pre-industrial climate. 3 times. The amplification factor is consistent with what the Kornhuber framework predicts for quasi-resonant patterns under elevated baseline warming, and we covered exactly this Rossby wave amplification framework 2 weeks ago in our video on the worst drought in modern American record, and again in our video from May 15th on the Super El Niño implication, and again in our video from a few days ago on the heat dome rebuild, and again in our video from May 22nd on the stalled jet stream trapping the United States, and again in our video from May 25th on the global synchronized heat wave that just broke the United Kingdom's all-time May temperature record. The same framework, the same mechanism, the same atmospheric configuration appearing in different geographic dress, depending on which face of the wave is facing which region of the world on any given day. This week, the face turned toward the United States is the Omega block configuration with moisture-bearing flanks. Earlier this month, the face turned toward the United States was the heat dome configuration with the ridge anchored on different geographic locations. The wave is the underlying object. The face is what we see. Part 7. The heat side of the same block. Before we close out the structural argument of this video and look forward to what June is going to do, we have to address the part of the country that is not flooding. Because the same Omega block that is about to ring out the northern Rockies and the southeast is at the same time producing the most anomalous May heat in years across the northern plains. And we have to talk about it, because the people experiencing that heat right now might not realize they are inside the same configuration as the people about to experience the flood. This morning, Thursday, May 28th, the National Weather Service issued a heat advisory for portions of central Montana. The heat advisory was issued because feels-like temperatures were forecast to reach 101 degrees Fahrenheit. In Montana, in May, the feels-like value combines the actual air temperature with the moisture in the air to produce a human-perceived heat index. The air temperatures are forecast to be in the mid to upper 90s. The moisture being lifted northward into the ridge by the Omega block circulation is adding to the perceived heat. The result is a heat advisory at northern plains latitudes on the 28th of May. Bismarck, North Dakota, recorded 88 degrees yesterday. Today the forecast is for 92. Bismarck's climatological first 90-degree day of the year, averaged across decades of records, is June 7th. The pattern is 2 weeks ahead of schedule for that station. Multiply that displacement across the breadth of the northern plains and you have a regional heat anomaly running on the same calendar day as a regional flood forecast on the western and southeastern flanks. The northern plains are the central core of the ridge. The ridge is the hot core of the Omega. The flooding flanks are the precipitating legs. Same letter, different stroke, same configuration. The Bismarck Forecast Office, knowing this configuration, issued a red flag warning for the 7 westernmost counties of North Dakota this morning. Divide, Williams, Mackenzie, Golden Valley, Billings, Slope, and Bowman. The red flag warning cites afternoon temperatures climbing into the upper 80s to mid-90s, humidity values dropping as low as 15%, and south to southeast winds around 25 miles per hour, with gusts to 40. The fire weather conditions on the ridge are operationally indistinguishable from peak July fire weather, and it is May 28th. 5 additional red flag warnings are active across the western and southwestern United States as of mid-morning today. The Henry Mountains and Grand Staircase fire weather zones in Utah, with relative humidity as low as 8 to 10% and gusts to 40 miles per hour. The Little Colorado River Valley and Painted Desert in Arizona, with relative humidity 7 to 14% and gusts to 45. The North Fork Zone in Colorado, an expansion zone covering southeastern Utah. 6 red flag warnings, 6 geographic zones, all on the same morning, all on the same omega block. Now, if you look at where those fire weather zones sit on a map and you look at where the flooding zone targets sit on a map, you will see something that should clarify the entire structural argument of this video. The fire weather zones sit underneath the central ridge of the omega. They are the dry, hot, descending air core. The flooding zone targets sit along the flanks of the omega, where the moisture transport is concentrated. The same wave that produces the fire weather conditions in southern Utah produces the flood target conditions in the northern Rockies. They are not separate weather stories. They are the same weather story at different positions along the wave. This is what we mean when we say one configuration, 4 hazards. The block produces flood risk on its western flank. It produces flood risk on its eastern flank. It produces fire weather risk along its central ridge. It produces heat dome conditions underneath the central ridge. 4 hazards, 1 wave. The Pacific Northwest on the leading edge of the Western Trough has a slight risk severe weather outlook from the Storm Prediction Center today for western Idaho and east of the Cascades in Washington and Oregon, with severe wind gusts forecast at 60 to 85 miles per hour, large hail possible, and the possibility of a tornado. That is the wedge edge of the Western Trough doing its work. Same omega, 5th hazard, different geography. And every one of these hazards is happening because the configuration is locked. The flood risk on the flanks is happening because the moisture transport into the flanks is continuous. The fire weather under the ridge is happening because the descending air column on the central ridge is sustained. The heat under the ridge is happening because the warm core is anchored. The severe weather on the western leading edge is happening because the trough boundary is producing the dynamical lift for convection. If the configuration were moving normally across the continent, no single region would experience any of these hazards for more than a day or two. The fronts would translate eastward. The risks would shift. The country would see a normal succession of weather over the course of a week. But the configuration is not moving normally. The configuration is slow moving. The hazards stay in place. The risk window stays open. The exposures compound. And the part of the configuration you are standing in today is not a random outcome. It is a geographic consequence of where the legs and the central ridge of the omega are anchored when the block formed earlier this week. If you are in the northern plains, you are inside the ridge. If you are along the western leg, you are inside the trough that is going to deposit the weekend flood. If you are along the eastern leg, you are inside the trough holding the northeast cool and cloudy. If you are along the southern stream under the Caribbean moisture feed, you are inside the corridor where next week's flood pulse will build. Same omega, same calendar day, different geographic accident of latitude and longitude determining which face of it you experience. This is the same configuration. This is the same wave, different faces, same omega. And every one of us in the United States is standing in a different part of it today. Part 8. June opens under the block. Meteorological summer begins on Sunday, June 1st, 2026. The first day of the season that the agricultural and water resource communities watch most closely for the year shaping moisture and temperature patterns that determine harvest outcomes, reservoir levels, and fire season severity. June is the wettest month of the year for the Northern Rockies. June is the second wettest month for the Southeast. June is the climatological pivot from spring patterns to summer patterns for most of the continent. And June 2026 is going to open underneath the omega block we have been describing. The Weather Prediction Center's discussion projects the block holding through approximately Wednesday, June 4th, before the configuration turns more zonal mid to late week, That means the first 96 hours of meteorological summer will unfold under the same atmospheric configuration that defined the final week of May. The block is not just a late May feature, it is the opening configuration of June, and that is the operational verdict that the thumbnail on this video carries. June will be a problem, not as forecast wishful thinking, not as alarmism, as the operational projection of what the Weather Prediction Centre, the regional offices, and the public-facing pattern scale forecast consensus are all saying about the configuration that is going to define the opening of the calendar's most consequential weather month. The forward-looking statement on the public-facing forecast included the phrase, "Southern downpours will likely worsen later next week." Later next week, in the context of a statement made on May 28th, lands in the first week of June. The mechanism is that as the block de-amplifies through the early week of June, the Caribbean moisture that has been loading into the eastern leg of the Omega all this week starts coming back south and east across the southeast. The Atlantic side flank rains that have been steady through the weekend transition into the heavier convective pulses that the relaxing block can no longer hold off. The second moisture pulse, the worse one, hits ground that has not had a meaningful drying interval since the first pulse this weekend. This is the cascade. The first pulse this weekend over the northern Rockies, the second pulse next week over the southeast. The cascade is the multi-week unfolding of a single continental configuration, releasing its moisture load progressively across multiple regions as the block slowly breaks down, and the calendar layer adds an additional element. June 1st is also the official opening day of the Atlantic hurricane season. The National Hurricane Center, on the same morning the Omega block was named by multiple forecast offices, issued its routine Atlantic tropical weather outlook. Tropical cyclone formation is not expected during the next 7 days. That is the verbatim language from the National Hurricane Center in the Atlantic outlook issued at 8 in the morning Eastern Time today. No formation expected. Next 7 days. That does not mean the Atlantic is empty. It means there is no organized closed circulation tropical cyclone forecast to develop in the next week. It does not mean there is no moisture. There is enormous amounts of moisture, and the moisture is being actively transported into the continent through the eastern flank of the Omega block. We covered the distinction between unorganized moisture surge and organized cyclogenesis in detail in our video from yesterday. The criteria for tropical cyclone formation require a closed surface low, a warm core, organized convective banding, and an NHC invest designation. None of those features are present in the current Caribbean moisture pool. The moisture is real, the flood risk is real, the tropical cyclone is not. Both things can be true at the same time, and on the morning of May 28th, both things are true. But the calendar coincidence is the kind of detail that gives the overall configuration its narrative shape. June 1st is meteorological summer. June 1st is hurricane season open. June 1st is when the block, after a week of holding, is forecast to be most fully in place. The first day of summer, the first day of hurricane season, and the day the block sits at peak amplitude all line up on the same calendar position. And the ENSO backdrop is another piece of the calendar narrative. We covered the warming trend in detail in our recent video on the heatwave forming in the Pacific. The Climate Prediction Center's most recent ONI release came in at plus 0.11 for the February-March-April season of 2026. That value puts the equatorial Pacific in ENSO neutral status, with a documented warming trajectory toward El Niño onset. 3 seasons ago, in October through December of 2025, the same index was at minus 0.55. The system has swung positive 0.66 degrees in 3 seasons. The Climate Prediction Center has an El Niño watch in effect. The probability of El Niño onset in the May, June, July season runs in the 82 to 98% range across different forecast products. The probability of persistence through the 2026 to 2027 winter runs at 96% in the most recent ensemble projections. We are about to enter an El Niño year. The warm baseline state of the eastern Pacific that the public-facing forecasts have been calling sultry is, in part, the ocean loading for the El Niño that is about to develop. That El Niño development is going to interact with the hurricane season opening in ways that are partially predictable and partially uncertain. The standard understanding is that El Niño tends to suppress Atlantic hurricane activity through enhanced wind shear, but the suppression takes months to fully develop. The early season window, June through early August, can therefore see significant Atlantic activity, even in years that ultimately become suppressed. The historical analogues we covered in the previous source documents include 1933, which was the second most active Atlantic season in the pre-satellite era during a similar El Niño transition with record warm Atlantic SSTs, and 2013, which saw above-average named storm counts despite borderline El Niño onset, with activity weighted to the early season Caribbean and Gulf. The current configuration matches those analogues closely, so the calendar position layers on top of the dynamical configuration to produce a forecast environment for early June that is operationally distinctive. The block is in place, the moisture is loaded from both oceans, the flood pulses are sequenced, the hurricane season opens into a basin where the moisture is real, but the organisation is not yet. The ENSO state is crossing into El Niño onset, and the first 100 hours of meteorological summer unfold under all of it. And we have to be honest about what this video is and is not claiming, because the alternative framings that get attached to configurations like this in the public conversation can be loud. We are not claiming this configuration is unprecedented. We are claiming it is at the high end of clarity for late May. We are not claiming it is engineered. We are claiming it is the textbook expression of a dynamical mechanism that the peer-reviewed literature documents. We are not claiming the National Hurricane Center is hiding a hurricane. We are claiming the moisture pool in the Caribbean is producing a flood forecast for the southeast, which is what the NHC's own outlook reflects in its plain language. We are not claiming the ensembles are wrong. We are claiming the convergence across three major model architectures from three different countries on the same forecast configuration is the operational reason confidence in the projection is high. There are public framings that attach to configurations like this. The framing that the abrupt flip from continental drought to continental flood is evidence of deliberate weather modification has been around for years. The energy budget rebuttal applies directly. HARP operates at an upper bound of approximately 3.6 megawatts of radiated power. A continental omega block of the configuration documented today involves continuous atmospheric energy flows on the order of 10 to the 22nd joules per day, integrated across the wave structure. The mismatch between the HARP energy budget and the continental atmospheric energy budget is on the order of 17 orders of magnitude. There is no operational mechanism by which a several megawatt facility could force a continental scale synoptic configuration. The dynamical explanation we have walked through, Arctic amplification compressing the meridional temperature gradient producing a slower polar jet, producing larger waves more prone to blocking with both ocean basins running warm, is sufficient to explain the observed configuration without invoking deliberate engineering. The framing that the National Hurricane Center is suppressing a tropical cyclone forecast for political reasons has been gaining traction in certain online ecosystems lately. The NHC's outlook is signed by named forecasters, issued on a fixed schedule, and built on satellite imagery and model output that is independently available to anyone with an internet connection. The cyclogenesis criteria require dynamical organization that the satellite imagery clearly shows is not present. The moisture is real. The cyclone is not. Both things can be true. The framing that the ensembles are coordinated to produce a politically convenient forecast collapses on its own structural premise. The European Centre for Medium-Range Weather Forecasts, the United States National Weather Service, and Google DeepMind operate from three different countries, on three different model architectures, with three different verification systems. The May 28th forecast convergence on the Omega block configuration, the Northern Rockies weekend flood target, and the southeast worsening into early June represents independent verification across all three model families. Coordinated falsification across three independent institutional pipelines in three different jurisdictions on a fixed daily output schedule is not operationally possible without leaks. The convergence is what raises confidence. The convergence is the reason the regional forecast offices and the Weather Prediction Center can all name the same configuration on the same morning with consistent language. Let me give you the way the ENSO crossover specifically interacts with the next several weeks of the configuration, because it matters for understanding how this June fits into the longer arc of the year. The Climate Prediction Center's most recent monthly ENSO discussion identified the Eastern Pacific subsurface temperature anomaly as the leading indicator of the developing El Niño. The subsurface anomaly at 100 meters depth has been building since early 2026 and currently sits at plus 5 to 6 degrees Celsius above the long-term average for the calendar position. That subsurface heat is the reservoir from which the surface El Niño will develop over the coming months. The mechanism is that westerly wind bursts along the equator drive the surface waters eastward. The subsurface warm pool slowly upwells along the eastern Pacific coast, and the surface temperature anomaly emerges over several months. The first surface signature appears as ENSO neutral with warming trend. The next signature is the formal threshold crossing into El Niño. The next signature is the strong event threshold, defined as plus 1.5 degrees Celsius sustained anomaly. The next signature, which the most recent CFS of Theodore and NMME multi-model means, are pointing toward for late 2026, is the super event threshold at plus 2.0 degrees Celsius. We are at the first stage of that sequence right now. The most recent only release at plus 0.11 for the February, March, April season is the formal first crossing into positive territory. The trajectory is upward. The probability of formal El Niño onset in the next several months runs at 82 to 98% across different forecast products. The probability of persistence through next winter runs at 96%. The trajectory beyond the basic onset, toward the strong or super thresholds, is more uncertain, and the spring predictability barrier means that forecasts beyond the next 6 months carry larger error bars. But the underlying ocean state, the loaded subsurface, the documented surface warming trajectory, and the convergence across major forecast systems all point in the same direction. What this means for the Omega block we are watching this week is that the eastern Pacific moisture loading the block's western leg is not a temporary condition. The basin will run warmer for the rest of the year. The atmospheric moisture available to the western leg of any future block, on any future configuration, will be elevated for the rest of the year. The both ocean feed configuration we have been describing this week, in which moisture is being lifted into the same continental airspace from both the eastern Pacific and the western Atlantic simultaneously, is going to be available to future blocks for the rest of 2026. The configuration this week is therefore one expression of a state the atmosphere will continue to be in for the next several months, and the Atlantic hurricane season, which we covered in detail in our hurricane season preseason video, opens into this state. The historical analog seasons that we identified in that video included 1933 and 1977, both of which were transition years from neutral or weak La Niña into El Niño. 1933 produced the second most active Atlantic season in the pre-satellite era. The early season Caribbean and Gulf activity in transition years has historically been weighted toward the first 2 months of the season, because the wind shear suppression from El Niño takes time to fully develop. The current configuration, with its Caribbean moisture loading and its top decile precipitable water values over Florida, is operationally consistent with the historical pattern of early season activity in transition years. This does not mean a hurricane is forecast for next week. The National Hurricane Center's outlook explicitly says no tropical cyclone formation expected in the next 7 days, and we accept that outlook because the NHC is the operational authority and its criteria for forecasting cyclogenesis are well established. What it does mean is that the operational backdrop for the entire month of June 2026 is the kind of configuration in which Atlantic activity has historically clustered in transition years. The Omega block we are watching this week is one configuration of that backdrop. There will be others. The dynamical explanation is sufficient. The physics is well documented. The configuration is consistent with the peer-reviewed literature on Arctic amplification and quasi-resonant Rossby wave amplification. The forecast convergence is independent across 3 architectures. The historical precedent for what slow-moving Omega blocks do over saturated ground with both ocean moisture feeds is unambiguous. Every one of these elements points in the same direction. The block is locked. The flood phase is starting Sunday. June will open under it. Part 9. What the sky will have to do to release us. We are going to close this video the way we opened it, with the central thread held in mind. The atmosphere over the United States has drawn a shape that locks the continent in place. The shape has been named in 5 regional forecast offices on the same morning. The shape is forecast to hold for another week. The structural midpoint of how long the shape will persist is happening today. The flood phase, which is the second half of what this shape does, is just beginning. But the configuration will eventually break. Blocks always do. The same dynamical processes that produce the block will, sometime in the next 7 to 10 days, produce its dissolution. The question worth holding on to is what configuration of atmosphere is required to end this one, and what the country will look like when it does. The mechanism that ends a block is typically the regeneration of the meridional temperature gradient. The block forms when the gradient weakens and the jet slows. The block ends when the gradient steepens enough to push the jet back into a more zonal flow. The configuration of the polar atmosphere matters. The Arctic temperature anomalies matter. The position of the polar vortex matters. The intrusion of any large cold air mass from the polar regions can sharpen the gradient and force the jet to regenerate its strength. In late May, the polar regions are already losing their winter cold reservoir. The available pool of cold air to push against the ridge is smaller than it would be in February or March. This is part of why blocking patterns in late spring and early summer tend to persist longer than blocks in midwinter. The gradient regeneration mechanism is weaker because the cold side of the gradient is itself weaker. The atmosphere has less to work with when it tries to break the configuration. The forecast for when this block breaks, based on the Weather Prediction Centre's projection of more zonal flow mid to late week of the first week of June, is approximately Wednesday or Thursday, June 3rd or 4th. That timing implies that the block will hold through Sunday, hold through Monday, hold through Tuesday, and then begin to release. The release will not be instantaneous. The block will de-amplify over a period of 1 to 3 days as the western trough opens up into a wave and translates eastward. The closed upper low over California will detach. The closed upper low over southeastern Canada will weaken. The ridge in the center will retreat northward. The continental flow will return to a more typical pattern. But the moisture deposited during the block's hold will still be on the ground. The basins that received heavy rainfall on Sunday over the northern Rockies will still be processing that runoff Wednesday and Thursday. The southeast basins that received the southern downpour pulse later in the week will be processing that runoff into the weekend after. The block's effect on the ground will outlast the block's effect on the upper atmosphere. The flood event will translate downstream through the river systems for days and weeks after the configuration itself releases, and the calendar will keep moving. June 2nd, June 3rd, June 4th, June 5th. Meteorological summer continues into its second week. The Atlantic hurricane season is now open, and the basin will spend the rest of June in the early season activity window. The El Niño development trajectory continues. The ENSO crossover that just crossed zero in the most recent ONI release continues into positive territory through the summer. The block we are watching this week will be one of the early configurations of a year that, by every indicator we can measure, is heading into the kind of state that produces above baseline weather extremes through its remaining months. This is the part where we have to be careful, because forecasting beyond 7 to 10 days is operationally limited, and the public-facing communication of multi-week or seasonal outlooks is fraught with overstatement. We are not going to project specific events in late June or July. We are going to project the underlying state of the atmosphere and the climate system. The state is loaded. Both oceans are warm. The Arctic gradient is compressed. The polar jet is slow. Blocking patterns are forming with above baseline frequency for the calendar position. The ENSO crossover has begun. The aerosol unmasking acceleration of the warm baseline is in effect. Every structural condition that produces extreme weather events is present. What that translates to in operational terms is that we should expect the months ahead to keep producing configurations like the one we are watching this week. Not the same configuration. Different configurations, different blocks, different geographic targets, different specific hazards, but the underlying dynamical machinery is generating the configurations at a rate that the climatological baseline did not anticipate. The block this week is one, the next one will follow, and the next one, and the next one. Each will look different in its specifics. Each will share the same underlying structural cause. The drought break video yesterday identified the cure and threat to same air mass framing for the moisture that ended the worst drought in modern American record. That framing extends naturally into this video. The same continental atmospheric machinery that produced the drought break also produces the flood pulse. The same configuration that holds the country dry on one face holds it wet on another. The atmosphere is doing both at the same time, and the rotation between the two faces is what produces the multi-week unfolding of consequences we have been describing. So the core mystery we leave you with is this. If a continental atmospheric pattern that the Weather Prediction Center and multiple regional offices are all openly naming as a textbook omega block has parked itself across the lower 48, with both oceans feeding moisture into its flanks, and is forecast to hold through the opening 4 days of meteorological summer, and the structural midpoint of its expected duration is today with the heavy rainfall phase still ahead, then the question is not whether June will open under flood pressure. The question is what configuration of the atmosphere ends this block, and how much of the next 30 days is already written into the wave structure we are watching today. The block is one expression of a longer story. The next configuration will be another. The atmospheric state that produced this one is going to produce the next one too. The question of when the country gets a sustained break from extreme configurations is, at this point in the year, a question without an obvious answer in the forecast literature. There is one final piece of context worth giving you, because it puts the configuration in its longer arc. The historical record of blocking patterns over the United States shows that the late spring and early summer blocks tend to be among the most consequential of the year for downstream water resources, agricultural outcomes, and fire season severity. The blocks that form in this window establish initial conditions for what the rest of the warm season will do. A block that deposits a multi-day flood pulse over the northern Rockies in late May resets the snowpack to runoff transition for the entire Missouri Basin. A block that drives multi-day rainfall over the southeast in the first week of June modifies the soil moisture state for the entire summer growing season. A block that opens hurricane season with an active moisture-loaded Caribbean influences the early season cyclogenesis probability for the next several weeks. The configuration this week is therefore not just a weather event. It is one of the initial condition-setting events for the rest of the warm season of 2026. That framing matters for how we should be watching the next 10 days. The forecast over the next several days is operationally robust because the timescale is short. The longer-term implications of the configuration, what it will mean for water resources in the Missouri Basin through July, what it will mean for soil moisture across the southeast through the growing season, what it will mean for Atlantic hurricane activity through the early season window, are less precisely forecastable, but follow from the same underlying state. The state is loaded. The block is one expression. The cascade of consequences extends downstream in time as well as downstream in space. And the closing question we keep circling back to is whether the underlying state will produce another block of comparable persistence within the next several weeks. The dynamical machinery that produced this one is going to continue operating. The Arctic gradient will continue to be compressed. The polar jet will continue to be slow. The ocean basins will continue to be loaded. Every structural precondition for the next block is going to remain in place after the current block releases. The probability that we see another configuration of comparable persistence within the next few weeks is, based on the underlying state and the historical record of how often these configurations cluster in warm seasons with this kind of loading, substantially above the climatological baseline. We are going to keep watching through the weekend, through the first week of June, through the cascade that follows. The block is the configuration, the flood is the consequence, the release is somewhere on the horizon, and what comes after the release is the next configuration, which is being assembled in the upper atmosphere right now, by the same mechanisms, on the same scaffold, with the same loaded ocean basins underneath. The sky over America in the summer of 2026 is not going to be a quiet sky. The block we're watching this week is the opening line.